So we'll go ahead and get started now. I don't want people to wait too long. So hello, everyone. I'm Bo Saulsbury with Pacific Northwest National Laboratory. Welcome to our Energy Storage at PNNL webinar. This is one in a series of webinars where we talk about energy storage topics. Today's topic is going to be pump storage hydropower. And we have a panel of experts who are going to talk about that topic with us in a few minutes. We're going to give you a little background information and then get started. We have the folks here who are going to talk, but we want it to be an interactive webinar. And so I think you can see in the chat that we welcome folks, audience members, to join on video to ask questions. They can then mute themselves and ask questions, or they can participate by questions in the chat. But we do ask that everyone be courteous, respectful of the speakers and of each other as we do that. So thank you for that. Just a quick overview of our topic today. Currently, pump storage hydropower provides about 90% of the installed utility scale energy storage capacity in the United States. So we want to get at what is the current value of pump storage in terms of moving us towards our clean energy future. What's the role in supporting clean energy, and what are the challenges to that? And we have these three expert panelists who are out doing work in the field, in the real world, at bringing about pump storage hydropower as a viable option for long duration energy storage. I'm just going to give each panelist name and what their title is with the organization they're with. They'll introduce themselves again when they speak. Our first speaker today, though, is Mike Manwaring. He's with Stantec. He's a power and energy consultant with them. The second speaker is Debbie Mersch. She is the Director of Business Development at GE Renewable Energy. And then our third speaker today is going to be Eric Steinley. He's the Executive Vice President with Rye Development. And with that, I would ask our first speaker, Mike Manwaring. Mike, if you will activate your video and your audio and come on. Thank you, sir. If you would, please introduce yourself and take it away, please.
Alrighty, I appreciate it, Bo. Let's see, I'm going to start my slides as soon as I can figure that out. All right, Bo, can you confirm that you can see my slides okay?
Yes, we see them just fine, Mike. Thanks.
Already, great, thank you. So as Bo said, my name is Mike Manwaring with Stantec. I serve as our Western US energy sector lead, and I've been working on pump storage projects for at least the last 15 years or so. Anything from project planning and development to permitting and FERC licensing to contracting strategies, bid evaluation, and then lately a lot has been market assessments and industry outreach. So I appreciate PNNL hosting this today. I've watched a few of the panels recently on YouTube and think I consider this our own little PNNL TED Talk. So I appreciate this. Specifically, I got to watch the session hosted by Jeremy Twitchell on long duration energy storage. So I'm not going to plan to get into how pump storage operates, but if folks want to ask that question, I'm happy to go through there. Really today, my role is kind of history of pump storage development and then present some ongoing trends. So let's get started. Having a little trouble in the screen here. Okay, so Stantec as a company has over 60 years of pump storage experience. We've been responsible for constructing a little over 17,000 megawatts of pump storage globally, and then an ongoing trend since the last probably 20 years has been huge refurbishment of the existing plants. And so we've been the designer for about 17,000 megawatts of refurbished pump storage globally. Our kind of pitch is we're the engineer of record for the last two pump storage projects built in the US, and 40 megawatt project in San Diego, and then a 1,000 megawatt project in Rome, Georgia. We were the engineer of record for the largest pump storage project that was ever built. That's in Bath County, Virginia, and the highest head project built, that's Chara in Bulgaria. So let's see this slide here. Sorry, Bo, I'm having a little trouble there. This is a little bit about kind of just the US fleet that I wanted to share. So these are the existing plants. There's 43 of them, basically concentrated on the eastern US, but certainly about a third of them are on the West Coast or the Western United States. About a third of the existing pump storage plants are federally owned, whether that's TVA, the Corps of Engineers, Bureau of Reclamation, and then about 2/3 of them are utilities. The smallest plant is about 15.5 megawatts, and the smallest unit is 4.2 megawatts. Sometimes that's important for scale because a lot of times people think huge when it comes to pump storage. So the largest plant I mentioned is a little over 3,000 megawatts. That's the Bath County plant in Virginia. And then the largest unit happens to be there as well. It's a little over 500 megawatts. These are domestic numbers. So Deb, who will come a little later, may have a bigger global picture. So the oldest unit in the United States, or the oldest plant, was developed in 1929 in Connecticut, and that plant is 15.5 megawatts. And then the youngest is the Lake Hodges project in Connecticut that was commissioned in 2012 at 40 megawatts. So sometimes people forget that we do have one probably less than just a little over a decade old. Here is that project, the Lake Hodges project in San Diego. The owner is the San Diego County Water Authority, and commissioned in 2012. And this was really built as part of their emergency water storage project. All right, this is the eye test chart. I apologize to everybody, but this is kind of the focus of what I'm going to talk about today. So here on the left, kind of a time, across the top, a little bit of the little history and the development characteristics of pump storage. Really in the 60s to 90s, both the US and global development was pretty significant. Typically, pump storage projects were partnered with either nuclear or coal plants to allow both of those, nuclear and coal, to operate at a pretty steady rate. And the pump storage project was the flexibility associated with that. Deregulation happened, and so then we get into the 2000s, and we started to see the early development of renewables. And so the first projects I started to work on in the mid 2000s started to account for what is the variable renewable energy from wind and solar. How is that going to get integrated into the system? So that was some of the first real interest of utilities around that time in 2000s, kind of this rebirth of pump storage, and it was mostly associated with renewable energy coming online. Keep in mind also at that time, there was a lot of work on upgrades of existing plants. And the focus of those operational characteristics, so this is the second column, was a bit of a morning peak, but then recognition of the large evening ramps. This was kind of before what we all collectively know as the duck curve happened, but it was starting to see some pretty big ramps in the evenings. Some of the challenges associated with developing pump storage in the 2000s was really the large capex of the projects and the start of uncertainty related to markets. And we started to have concerns related to the FERC licensing side of things, but that really came a little later. The column there on the far right, I wanted to just kind of highlight some advancements from a technology standpoint. So in the 2000s is really where we started to see adjustable speed pump turbines globally. And Deb, I'm sure, can talk more about that later on, but this is when projects started to be able to integrate that. So down in the 2010s, when I started working on more and more pump storage projects, we talked about grid scale energy management, or bulk scale energy management. That's really the term that has evolved into like long duration energy storage. So in LDES, we used to use the term bulk storage or grid storage, but certainly by the 2010s, we were keenly aware of the duck curve. Integration of renewables was often the term we talked about when we were looking at pump storage. But one of the biggest challenges, and a lot of times when I talk to people, they forget this, was we had really low cost natural gas. We still have low cost natural gas, but that could serve a lot of the kind of grid management, at least from the generation side, fast starts that pump storage could. And then when we would talk to both utilities, grid managers, the integrated resource plans for a lot of utilities didn't look out far enough to see the need for long duration energy storage. So some folks may remember the Iowa Hill pump storage project in California. One of the challenges of that, it was the client recognized the need for it, but their planning group didn't see the need for it now. Contrast that to 2020s, a lot of IRPs really start to see a need for long duration storage as they manage their assets. From a technology advancement in the 2010s, and again, I'm lumping 10 years there, so it could be a little bit more. We started to see the design of closed loop pump storage. And by that, I mean, it's not connected to a navigable waterway. So these were specifically designed upper and lower reservoirs that were off stream. And I know Eric's going to have some good examples of that later on. In around this time period, there was a lot of advancements from a construction standpoint. We had RCC, or roller compacted concrete dams. We had significant advancements in the liner systems. And as many folks know, the whole idea of CFD and advanced modeling grew significantly in this time period. So from getting into the 2020s, kind of where we are, generally today, we continue to talk about the need for renewables management, grid resiliency, system and grid inertia needs with retirement of coal, big, large machines providing system inertia. There's that recognized need for it. The operational characteristics, again, evening ramps, there is certainly a need and recognition from a long duration energy storage. When we talk to utilities, the developers, that is a big component of what we're focused on, whether that's 6 hours, 8 hours, 10 hours, or longer. And we see this in system and grid disturbances. A couple of years ago, out on the West Coast, when we had rolling brownouts, blackouts in California, the Castaic pump storage project provided huge benefits to the city of Los Angeles, keeping the lights on. Development challenges that we're again facing today. There's certainly a lack of revenue certainty, and I know Eric will talk a little bit about that. I think, and somewhat until recently, there's been this perceived competition between energy storage technologies. So what I mean is, the short-term sub 4-hour battery, lithium ion, and pump storage. I've worked on a couple projects where we're actually looking at integrating lithium ion batteries into a pump storage project when we find that the economics are advantageous. So I don't think certainly lithium ion are a competitor to pump storage anymore. They're very, very compatible. And then FERC licensing, that is continued to be a little bit of a challenge because that's kind of proxy for it takes a long time to develop a pump storage project, anywhere from 6 to 10 years, depending on your site and your permitting needs and your state and federal agencies. From a technology standpoint, in the last couple of years, we've focused on smaller, or what we're calling modular pump storage. And these are 5, 10 megawatt projects that kind of focus on smaller capital costs. Certainly tunnel boring machine technologies have advanced in the last 10 to 15 years, the ability to move rock or excavate rock very quickly. And then I put in there some of the advancements, Department of Energy. Last 4 or 5 years, there's been big efforts from DOE on funding potential studies. The Loan Program Office, the Jigger Shaw runs, there's an opportunity for financing. So there's been huge upside from the Department of Energy. And then kind of looking out what's next. And again, this is Mike's crystal ball. I think continue to focus on replacements of thermal retirements. And Deb may touch on this, but the three kind of main sources of flexibility that we have out there, we have coal, we have gas, and we have hydro. As coal starts to be retired from a decarbonization standpoint, natural gas may find that too, and hydro, including pump storage, has that huge ability to provide flexibility to the grid. So I kind of see that as a big opportunity for any long duration technology, but pump storage in particular. Operational characteristics, certainly continue to see the evening ramps. I think in California, we're seeing 17,000 megawatts or so over a couple hours. Grid management, stabilization, and then energy security, I think becomes a larger recognized issue that any energy storage technology can support. What will be some continued development challenges? Maybe none. Maybe as we start to build long duration projects, we won't see this as much. But I do see utilities that are looking to procure these projects having concerns over what really a pump storage project needs is a long-term power purchase agreement, a way to pay back that pretty significant investment. Because many of these projects that are, say, over 400 megawatts, their costs start with $1 billion. And so the developers of these projects, and I'm sure Eric will touch on this, really need some of that long-term security. But from a utilities perspective, they sometimes hesitate looking at a 50+ year asset, investing in that long-term power purchase agreement when the technology development of what's next may cause them a concern. It's not the recognized need. I think that's clear. It's how do they enter in a contracting mechanism? And then from a technology advancement, what's next? Perhaps, hopefully, that those of us on the development side, new market designs that value all of the different attributes of a long duration storage technology like pump storage, whether it's decarbonization, whether it's energy security. Not sure which of those, but I'll kind of pause there in case there's any burning questions, because this to me is kind of the big history of development in the US and then looking forward.
Okay, Mike, thanks. Sorry I didn't want to interrupt you there, but you're eating into your Q&A time. So we got sort of the nod.
Okay.
That
I got one slide left, Bo.
Yeah. Okay. Sorry.
All right. So this is the Rocky Mountain Pump Storage Project in Rome, Georgia. And this is my last slide I'll focus on. It's the trends. And I'll try to get through this pretty quick. In the last 15 years, a lot of projects were pretty large, the 400 megawatts to over 1,000 megawatts, and they were focused on kind of low cost per kilowatt. And they were really led by the development community. We've seen smaller plants being looked at that focus on a low CapEx. And these are, again, 5 and 10 megawatt projects. And then recently, a lot of interest again from utilities and federal entities. And by that, I mean the TVAs of the world. A lot of those that are interested have existing pump storage in their portfolio, but other utilities that are looking at developing pump storage are facing, they may want to become balancing authorities. So they're looking at how do they provide that flexibility. Again, the recognized need for LDES. I know we had a panel on that just a couple of weeks ago, looking at grid security, resiliency benefits, and then a true understanding that it's a different function than a less than 4-hour battery. So they're really serving two things. And then I mentioned DOE and other federal funding opportunities. And what that's doing that I see is it's bringing a lot of interest from large infrastructure, like green infrastructure funds. So it's just, and these are just pictures of projects out there that I show. So Bo, I'll pause there. If there's questions now, I'll happy to answer them.
Yeah, we did have a couple of questions. I'll just put one out there and then we'll switch to Deb after this. And I'm going to blend some questions because you mentioned the difference between open loop and closed loop pump storage hydropower. And we had one question about using conventional hydropower resources that are already constructed in terms of developing projects. What do you see as the most likely scenario going forward for pump storage hydro in terms of what's in the pipeline now, the ones that are most likely to be quickly developed, say in the next 10 to 20 years? Is there a difference between open loop, closed loop, or how do you see that?
Yeah, that's a great question. And there's a huge interest in closed loop pump storage because of the minimal environmental impacts. The permitting needs are easier. There's even discussion of a faster licensing program from FERC because you're not connected to a navigable stream. And so your fisheries issues that are often a concern when it comes to hydropower are much, much less. The challenge that one is presented with is a cost. You're likely creating two existing new reservoirs, your upper and your lower reservoir. An open loop, most of the sites, nearly all the sites that I've looked at, they have an existing reservoir. So to your point, like there is already either existing lower, upper, or both. And so your cost can be significantly less if you're just either constructing one reservoir or you're just connecting two existing reservoirs. And so sometimes it's a cost perspective. You may have more or more significant environmental and permitting challenges if it's an open loop because of the fisheries aquatic issues. So your cost may be less, but your permitting time may be more. And so there's no lack of good project sites out there, but sometimes it depends on your overall cost and your overall time period for those.
Okay, thank you. Again, I apologize for interrupting you, Mike, and I'd like to give Mike a special shout out because he's coming to us from his vacation. So thank you, Mike. I appreciate the sacrifice there. So we may have some more questions at the end of the session once we go through all the presenters, but I want to give everyone their chance. So our next speaker is Debbie Mersch from GE Renewable. Debbie, are you lined up and ready?
I am, yes. If I do my share screen correctly.
Okay. And I just wanted to put everyone on notice, if Debbie disappears from video, it's because we're having some technical difficulties, but she'll continue to do her slides even if she's not on video. So thank you.
So thank you very much, Bo. Again, I am Debbie Mersch with over 40 years experience in the industry. As a matter of fact, right out of college, the first plant I actually saw was a pump storage project. So I've been with pump storage since the get-go and still continue to love it. Just a little bit about GE. I don't know if you're aware or not, but GE actually has been broken into 3 separate companies now: aerospace, healthcare, and then all of the power. So for example, everything now is rolled into conventional and renewable into one. So actually GE has the benefit of that we sell it all, so we can compare it all, and we can give you very unbiased pros and cons to each of the different technologies, which I think offers us a unique perspective. Just as concerning GE Hydro itself, we're over 100 years old. We've done over 350 plus gigawatts installed worldwide and have 30% of the world's pump storage projects globally. So if we just get into global, I wanted to show you this screen. Let me see if I can get rid of that. There we go. The interesting thing on how pump storage started is it actually almost linearly, and anything I show you now will be globally, not within the United States. But what's interesting, as you can see, is that it's linear. So anytime there was a new nuclear plant built, they tried desperately to get a pump storage project there. As a matter of fact, many of the nuclear sites were determined based on the ability to add a pump storage project right next door. And why did you want to do that? Because with nuclear, you want to turn it on and just let it run. You don't want to mess with changing or following the ups and downs of electrical demand. You wanted to use the pump storage plant to do that. So that's what happened. And then once nuclear stopped, pump storage stopped. It went to sleep for several years. There was a little bit of action in Japan because they're an island and they needed to have backup. But actually then pump storage was renewed when the renewables got so popular and started the instability on the grid, because if the sun doesn't shine and wind doesn't blow, of course, you can't turn everybody's lights off, and that's where pump storage became very important. Just to show you how it evolved, I was talking a little bit about it, but globally, there's just over 200 gigawatts installed. You can see China, which is just going gangbusters. Actually, right now they have over 30 gigawatts installed, but their plan right now is to go to double that by 2025, and then double again. So go from 60 to 120 by 2030. So they just have a tremendous amount of pump storage planned. There's several reasons that drive that, but I think the most important thing that I see is why some of these countries, and you'll see on the global map I show why some of these countries are doing so much pump storage, is most of them have a long-term plan for their grid. unlike us that make very short-term decisions. Oops, we need another battery. Oops, we're short here. Oops. And so we're not optimizing our decision-making in the United States, at least. That's not a GE point, that's a Debbie Mersch point. But anyway, so this is kind of what the world looks like globally. What's interesting now, you talked about the world and what's driving the world, and there's all different things that are at Australia. They do have a to have our, which means they pump at night when, I'm sorry.
Debbie, you might want to shift off your video now. We're starting to get some sort of more feedback. So thank you.
Oh, all right. Is that better?
Yes, thank you.
Perfect. Thank you for letting me know. So again, there's all different drivers throughout the world. For example, in Australia, they can do arbitrage, which is normally how pump storage did make its money globally, which was sell high, buy low, to watch the price markets. You still see that in Australia. Another reason why Australia is building new pump storage is because they had a rolling blackout that they couldn't recover from. And that's kind of when they said, okay, we're done. Some other interesting things is, for example, in Israel, even though it's a desert, they're building 4 new pump storage projects, not only for energy security, but also they don't want to have just 1 or 2 plants, because if they get blown up from the enemies, they're in trouble. So that's another reason why they're doing pump storage. The government's involved with it. But anyway, they all have really different reasons for why pump storage is making sense. But again, the common thread of all of these is that the governments, the countries are looking at long-term. They've got a long-term plan, which we desperately lack. We do it by state or little community rather than looking across the country. Whoops. Sorry. Trying to turn my slide and now it won't. There we go. Just one other thing too, that if we look at globally what one of the major issues are, even still for pump storage, it's really a lack of education globally. And one of the things that we get asked a lot is just, well, how does pump storage compare with a battery? And it's like comparing a little pimple to the globe. I mean, they're so different, but we tried to capture here is you can see that lithium ion batteries are very good for the small end of the spectrum. Please note that this is a logarithmic scale here. This isn't a linear scale. And above here is the discharge duration. And the one thing that's interesting is that batteries have before needing recharging of a couple hours. And actually, and you don't hear about this too much, but pump storage actually is perpetual, can be perpetual, especially an open loop, because if you've got a river coming in and you have it such that the reservoir is continually filled or it has water in it, you can run forever as long as that river's flowing. And I hope I just made sense on what I just said. But so basically you can look at pump storage as perpetual. And there's several plants in this country that can meet that. And I believe Helms is one of them. Rick Miller, I saw, was in the audience, and Mike, so you guys can correct me. But at any rate, the thing is if you look at ancillary benefits, they don't look that different, these different storage technologies. But the biggest thing is the ability to be there when you need it. And if there's rolling blackouts or a blackout like Australia had, a couple hours is not going to cut it, even if you have a bunch of batteries. And you really need the oomph and the inertia that big equipment can give you, like steam and nuclear and gas. But more importantly, hydro is in there too, as well as renewable. So just if we kind of summarize, storage of a pump storage is so much bigger than a battery. So for every 100 megawatts of pump storage, you need a ton of batteries for that. I think the other thing that's really amazing is just the life of pump storage. It doesn't charge itself out like a battery does. It's got a life of 40 to 80 years, and then additional when you rehab. So these last for a lifetime, which actually is why the dollar per kilowatt is cheaper in the long run. If you take a look at the life of what a pump storage is to a battery, limited environmental footprint, and most importantly, it's dispatchable. It's the only storage that is dispatchable. It's fast, it's quick, and it's capable of all different kinds of ancillary and balancing services. And then my last slide is just touching on what Mike did. He talked about the generation of pump storage, but actually from a OEM or a manufacturing point of view, we have made great strides in moving the technology. Some people say, oh, hydro, it's boring, it's old technology, but it's anything but. We use cutting edge technology because originally when these units were built, they were built like a nuclear plant, start up and sit or flex a little bit with the needs of the grid based on personal usage. But now with these renewables and quick, all of a sudden the clouds come over, these units now have been built with a variable speed technology, which allows them to load follow, to start up quickly, to go back and forth, and be much more responsive than they ever were in for your grandfather's pump storage projects when they were built many years ago. So that's all I have. I appreciate your time and thank you.
Thank you, Debbie. I appreciate that presentation. I wanted to open it up. I realized I didn't do that after Mike's for anyone who might want to ask a question live. So if anyone has a question they would like to ask, anyone in the audience that they'd like to ask Debbie live. If not, there's at least one in the chat. So there are a couple of lengthy questions in the chat, Debbie, that we might get back to you and ask you to respond to the questionnaire after the webinar. And we can do that with all the questions that are in the chat that we don't get to. But yeah, one question I had, you said that in terms of pump storage hydropower, China, your quote was China's going gangbusters. So it sounds like there's a lot of pump storage happening around the world, but not necessarily in the United States. Can you maybe give us some clues as to why that might be?
Well, actually, I point to two things. A lack of education and knowledge, like what I said. People believe it's old technology and they only want the newest widget. So we have a real problem with that, where again, I'm Bloomberg, for example, when I asked them, why aren't you writing in your investor grade newsletter every month about hydro? And he goes, because it's boring, it's not sexy. That was the main author of that newsletter, and I think that spoke volumes. But and then also I again, we just don't have a long-term vision, and it's pretty frustrating to me when we start having issues. For example, in Texas, what's the first thing we do? Because that's the only thing left at this point, is throw a bunch of batteries. And that isn't, and again, GE sells batteries. So, but it's certainly, we're not very smart on how we approach this. And I really believe that you need a long-term strategy, because that then dictates and will help form the markets on favorably these services that the other storage technologies provide will be correctly compensated in the markets, which they aren't right now. So those are the two things I really believe we need to focus on, and NHA has started doing that, but better education of the decision makers and a long-term strategy for our grid and for power in the future.
Okay. Well, thank you, Debbie. As I mentioned, we've got a pretty lively chat session going, and it's hard for us to answer them on the fly. So we've asked the panelists if we can commit to answering these questions after the seminar or after the webinar, those that we don't get to here. So we'll uphold that commitment because I don't want to impede on the next speaker. So
No
Debbie,
problem.
thanks again. Thank you,
Thank
Debbie.
you, sir. Thank you.
Appreciate it. And our next speaker, if he's ready, is Eric Steinley with Rye Development. He's got his slides here, and I'll turn it over to Eric. Thanks.
Good morning or good afternoon. Bear with me a second here. I'm going to try and figure out how to turn my camera on. It was working fine earlier. All right. I appreciate the opportunity to be on the panel. And Mike and Deb, thank you for the presentations earlier. I think it'll dovetail nicely with a bit of a developer's perspective, specifically in our case, closed loop pump storage that we're developing here in the US. I work for a company called Rye Development, and we're one of the leading platforms for new hydro development here in the US. And I've been fortunate enough to be in the hydropower development space for over 20 years now. A lot of that time has been developing more conventional hydropower and certainly smaller than the pump storage projects I'll talk about today, including the last major new hydro built in the state of Oregon. I sit in Portland, Oregon, and at least some of the projects I'm going to talk about today are projects with a specific focus on grid resiliency and energy storage on the West Coast. So oops, make sure I can switch slides here. Apologies, folks. I'm having a little trouble switching slides on my end. There we go. All right. So again, just a little bit of background here for Rye and our projects. We've got projects across the U.S. In addition to pump storage, we've got some traditional hydropower projects, primarily in PJM and MISO. Probably comes as a little bit of surprise to individuals that only 3% of the existing dams in the US have hydropower facilities. So a big portion of our set of development projects are new hydro at existing non-powered dams. Just wanted to share a little bit more on that. Transitioning a little bit to pumped hydro, and apologies, and continue to have trouble advancing the slides. Here we go. Our projects, our efforts in pump storage really started in the Pacific Northwest. And for the discussion today, I wanted to talk a little bit about, what is it that utilities want, or a developer's perspective in, what utilities need when they think about energy storage. So as Deb and Mike alluded to, for us, we need to have off-takers or a contractor for the projects to ultimately build them. And so, touching a little bit on what utilities want when they think about energy storage, what's the best solution for resolving capacity and reliability issues while ensuring low cost reliability for ratepayers. So, with a story beginning in the Pacific Northwest, some of you are probably aware in the audience that Washington State, despite having a lot of hydropower, didn't even consider hydropower a type of renewable electricity until really recently. So touching on Deb's comment about education, there's still a lot of work that we can do talking about the value of this type of resource. And while the debate over hydropower, in this case, specific to Washington State, carried on, some of the largest tech and manufacturing companies in the world have been building facilities in the Pacific Northwest because of the availability of carbon-free, low-cost power, which to a large extent has come from our existing hydropower fleet. So we certainly think the debate around hydropower, the Pacific Northwest, and certainly pump storage is changing again. And popular demand and policy have led to a major push for intermittent renewables, which is, both Mike and Deb pointed out, has caused an increased demand for market storage capacity, and maybe most importantly, reliability. So, talking a little bit about what utilities want, what's needed to move forward with new pump storage. I would say that one thing that's been working well is really talking about this resource in the utility planning processes. You don't have to go back very many years to a time, and Mike showed this in his slide, when we were not looking at storage at all in the utility planning processes, or IRPs. Number of reasons for that, but pump storage specifically has a really high effective load carrying capability, or what's referred to as an ELCC value, in comparison to lithium ion and shorter duration storage. So from a capacity contribution standpoint, pump storage is a clear winner. And I think it's important, Deb put that slide up of, comparing pump storage and lithium ion. And, it's very true that the two are complementary, the two are not really comparable, and if we're talking about capacity and reliability, lithium ion isn't even a storage product that's in the top 10 list for utilities, but a lot of it's getting procured. So it again comes back to making sure that we're educating people that there are projects that are ready to construct. There's projects that are certainly de-risked from a permitting standpoint. And these projects, as to Mike's point, there's a lot of sites throughout the United States where essentially we've got a homegrown storage resource where we're moving water around on the landscape versus some other type of storage project. And I was just on a call yesterday where we had a very large renewable energy and storage advocacy group suggesting that as of today there is no long duration energy storage technology out there that will be available until 2050, which is essentially which is of course not true, but there's still some work that we need to do there on that end. So I'll give a couple of just quick examples of projects. Following up on the ELCC value and sort of value in the system for utilities. This is a project RISE developing for Copenhagen Infrastructure Partners. It sits right on the Oregon-California border, 400 megawatts in size. It's a closed loop project. It's fully permitted. And where it connects into the grid, this particular project can provide value to a number of utilities in this location, which is pretty valuable from a developer standpoint and having that optionality. For this project, I'm happy to say we sent out our first construction notices as required in the license last week. And with still a bit of luck and finishing, the FERC design review process. We hope this project will begin construction in 2024, and it will be number 44 on Mike's list of operational projects.
Eric, I think your slides might be one behind. We're not seeing a slide for that project.
I apologize to the group. I am advancing them on my screen, but they're not advancing on.
Now we see the Swan Lake slide. Sorry.
I apologize. So this is the Swan Lake project, closed loop facility in Southern Oregon, fully permitted. I apologize. So just kind of, continuing on this discussion, and I guess I'm running a little short on time, so I'll pick it up here a little bit, and talking about making sure that these projects are being sited in locations where utilities and the grid can really take full advantage of these projects. Of course, there are a lot of sites for these, but you are limited geographically, and then probably most importantly, putting these in a location where utilities can really take advantage of them with existing transmission, or multiple utilities can take advantage of these projects in a cost-effective way. I guess I would put it that way. The project you see on this slide or depicted on this slide, this is a project we're developing in Washington State, the Goldendale Energy Storage Project. And the largest features you see from this project are 2 60-acre ponds. Everything else is subsurface in this, and HDR is assisting us with the engineering and design of this particular project. This project has been designated a project of statewide significance by the legislature in order to prioritize state permitting, which we just finished. And also because of its value in the grid to the Pacific Northwest. So what I mean by that is that in this case, this project will generate 1,200 megawatts of on-demand electricity for 12 hours. So that's enough, to provide on-demand carbon-free electricity for every residence in Seattle. And your land use impact here is 2 60-acre ponds, and the project's entirely on private land and immediately adjacent to the BPA transmission corridor. So just to give you some perspective on siting there, you would need thousands of semi-truck size trailers of lithium ion for a similar type of impact. Or if you're doing that with solar, you need 50,000 acres of land in Washington State. Or with wind, you need 7,000 acres of land. So from a land use and strategic development standpoint, this is a very valuable project to the state of Washington. All right, just a few more details on the Goldendale project in Washington. This project's entirely on private land. It is a redevelopment of an existing brownfield site. The land was historically associated with an aluminum smelter. And as I mentioned, we've finished the major state permitting for the project, and the FERC license is anticipated in the first quarter of 2024. So another thing I'll just touch on briefly is talking about community support for projects. I would say not that long ago, community support was really something specific to permitting and not much outside of that. But in an era now where all utilities are looking at a lot of new resources, wind, solar, storage, transmission, a variety of things, having community support is something that's pretty different than just worrying about permitting. And there's a lot of discussion for our projects, throughout the United States on energy equity. So one thing I would say that's, the case there when we're talking and engaging with utilities on this particular matter is that in communities where we have these projects, energy equity is not just rooftop solar. It's not an electric car in your garage. Really, it's an investment in renewable infrastructure that doesn't displace large areas of land and sustains low costs for decades, if not generations. And certainly hydropower, new closed loop pump storage is part of this. Yeah, for our Pacific Northwest projects, it's no mystery to residents here why our electricity is amongst the cheapest in the world. And new pump storage is an extension of this. It's a homegrown energy storage resource. It doesn't rely on a foreign supply chain, least amount of GHG impacts. And of course, ratepayers don't have to pay for it to be replaced every 15 years like they do with a lot of batteries. So lastly, I'll touch on this project that we have in Southeast Kentucky. We're partway through the permitting process here. Fascinating project. It's a redevelopment again of a brownfield site. This is an existing coal mining location where pump storage here can be added to the system in a very important way to increase reliability in the region as coal starts to come offline for very different reasons than popular demand and policy, which are the reasons we see on the West Coast. But because of the age of the facilities and it's a reliability alternative to building new gas. So with that, I think that is the end of my slides. I've included some information there about our company and then links to each of the 3 project websites I touched on briefly today.
Thank you, Eric. We appreciate that. You have got a lot of exciting things going on there with RIDE. It's great to hear about them. I will direct the first question to you, Eric, since this is still in your time slot, but I want to also invite Debbie and Mike to come back on video, and we'll open it up to to everyone after I give you the first question. And you touched on it a bit there on your final slide. You mentioned some regional differences between what's happening at your project in Kentucky and those in the Northwest. What are the regional differences in terms of pump storage hydro development in the U.S.? Are there differences in terms of the values the projects provide, or in terms of, getting them through the permitting process, or just are there differences? And if so, what are there?
Yeah, I mean, I think the value the projects bring, of course, is obviously the same. I mean, I think demands of these types of projects, depending on where they are, I mean, you can definitely see different demands as far as how they're sized, equipment, variable speed, fixed speed equipment, depending on how they're being used. Yeah, our projects in the Pacific Northwest are based on an environment where there was a rapid push for intermittent renewables, and we'll worry about storage and reliability later. A lot of popular demand for renewables and then policy that followed. We see a lot of demand elsewhere, especially in the mid-Atlantic at this point, from utilities for this type of resource, where reliability is certainly, something that they're planning around first and renewables second. And then also in those locations, a lot of the coal facilities are coming offline because they're old, right? And so there's a push for replacement, sometimes based on, actual policy needs in part of the region. But, solar's coming online in these areas. So there needs to be a capacity product. Gas is going to get built in some of these areas for sure. But this is, a good alternative. And actually provides additional resiliency than just, a story of gas and solar. So hopefully that answers the question.
I think so. And I would open it up. I don't know if either Mike or Debbie want to take a shot at that one, or if they want to move on to others. So Debbie?
I just have a couple quick. Number one, part of the issue is that our markets are not fully developed and compensating for the value of the benefit. The problem, utilities have been forced for years to give away those. This is free, so there's not a developed market. But the second thing is, think about it. We have gotten a plant than a pump storage plant. We have gotten a nuclear plant online faster than we have existing hydro plants. So there's certainly unique issues of permitting hydro over any other technology.
Okay,
in
yeah,
the US.
we touched on some of those, and I was going to ask Mike about that. What are some of the issues in terms of permitting in the U.S.? What does the typical development timeline look like for a pump storage project? I know there haven't been any developed in a while, but typically, what's the timeline, and what are some of the major holdups in that timeline, Mike?
Yeah, I think for the major holdups, maybe I'll even punt that, Derek. But I put in the chat because somebody had asked that question. We generally tell people 7 to 10 years, and that depends on the appetite for the people developing the project, and it depends really on your project site. Example: if a private developer has to kind of pause in increments of development to go back and get additional funding, sometimes that can extend the timeline. But we say if you start today with the bag of cash you need to develop your project, and you don't have to pause for additional funding or to go after your power purchase agreement, if all that can be done sequentially, it's about 3 to 3.5 years on your FERC licensing process, and another 3.5 to 4 years on your construction. All that really is dependent upon the size of your project and the use of existing infrastructure. I've got a project in California. We're looking at connecting 2 existing reservoirs. So our construction is a tunnel and a powerhouse. And so that construction window may be less than if you also have to build 2 additional reservoirs. But then when we look at these smaller modular pump storage projects, these sub 20 megawatt projects, those can be even quicker. Looking at using out of the box, whether it's precast concrete, whether it's large water storage tanks, those can be erected a lot sooner. And if you're using steel pipe, steel penstocks compared to installing an underground tunnel, there's ways to speed up that time frame. Deb mentioned the federal licensing, FERC licensing. If you're a non-federal entity, you have to go through that process. And while we look to speed that process up, generally about 3 years is around as fast as you can go from your issuance of your preliminary permit to your FERC license being accepted. Again, controversy of your project can can delay that. But I don't know if Eric wants to address more of that.
No, I think those timelines are right. I mean, on our end, we've mainly been focused on developing projects for traditional utilities. So the FERC license is very valuable. And I think the 6 to 8 year or 7 to 10 year timeline is correct until a project can be realized. So we're using private equity to get out in front of that, so the projects are fully permitted when utilities are actually vying for use of the facilities. However, I would say some of that is changing, and these are groups that are not RIE at this point in time, but there are developers now developing large billion-dollar plus projects that don't need a FERC license because they're entirely on private land and use groundwater. And on the offtake side, there are corporates now that are actually pushing on the doors of signing up for capacity products, which is a totally different conversation. Why a non-utility would need a source of capacity, right? And that's not, the need for that is balkanized, right? Just like our power grid around the US. But those groups, being willing to sign, creditworthy groups being willing to sign up for billion-dollar projects early on before FERC license or without a FERC license, I think rapidly changes that timeline. And the grid, and certainly I think everyone benefits from seeing some of those projects come online quicker.
Thank you for that. And I wanted to acknowledge Kurt Miller has his hand up, and I did not see that earlier, so I apologize. Kurt, would you like to come on and ask your question?
Yeah, hey, thank you so much. It's a great webinar. I appreciate all you guys are doing for hydropower and pump storage. We're a hydropower advocacy group in the Pacific Northwest. Northwest River Partners, and Eric's comment about education, definitely we embrace. But I wanted to ask Eric and maybe others, kind of what sort of polling you have seen in terms of support for hydropower pump storage. We know in the Northwest that hydropower in general has about an 80% favorability rating, and that's about the same as wind and solar. But I just was curious, how many people know about pump storage and what their relative favorability is, if you know that answer. Thanks so much.
Yeah, I mean, I can answer first. I mean, Kurt, the polling that Northwest Rivers provides is something that we refer to a lot. So thank you again to your organization and all the work that you're doing there. Most of our polling is pretty specific to our projects and not the technology generally. But we do track feedback on social media, all the project websites, general interest. And on our end, since we've been tracking this since 2019 or so, general interest has doubled every year. And polling related to that on the favorability side has been, in the high 80s, right? Across the board once people know about it. I think, part of the challenge is, and many of us will be at the RE Plus conference in Vegas in a couple of weeks, is that, pump storage in general, or, I guess the term non-sexy resources was thrown out earlier, is a really small portion of the conversation, right? And so I do think that's a hurdle to overcome. That's probably about the best I have to offer today. I think, again, for the industry as a whole and hydropower, being able to get out ahead of things a bit and understand where our weaknesses are from a permitting standpoint, but again, advocate that these resources are real, they're out there, there's projects that can be contracted now, is an important piece of it.
Yep.
Thank you.
Let me add one quick question, because I think that's a great answer. It's always project specific. And I think the industry is trying to do a good job to showcase the benefits of pump storage. But even some of the chat I saw, when we talk about decarbonization and the role storage reservoirs have, or pump storage can have, like, that's important for us to talk to our communities when we're having discussions about a particular pump storage project. We get questions a lot about, well, what is your pumping power? And right now, natural gas is often on the margins. So the pumping power for certain projects can be procurement of natural gas. But as we look out 2025, 2030 and beyond, what's going to be on the margins is probably more renewables. And so then we can more reliably think that we're going to be using renewables to pump up. So these projects, their footprint from a consumption standpoint becomes a lot more green. And then another one of the questions talked about water resiliency and what's the impact of drought on these projects. Well, a pump storage project doesn't consume water. it cycles it back and forth. Yes, there's a challenge with evaporation, and in some areas we've looked at whether it's covers or operational changes. But I think understanding how these projects operate with the larger environmental constraints, whether it's fisheries, drought management, greenhouse gases, when we talk to our stakeholders, I think they understand that like that's really important to how we design these projects. And so there's, as Eric alluded, there's a lot more acceptance and recognition of the benefits, because pump storage, you know, because of our history of development globally, we do have a bit of an environmental uphill battle to climb sometimes.
Well, I'm going to jump end all discussion. We're out of time. I want to thank our participants, Mike, Debbie, and Eric. Thank you so much for joining us today. We really appreciate the great work you're doing and all the great information you provided. We'll be in touch with you if we want to try to get some follow-up answers to some of the things we couldn't address in the chat. That's my fault because I just can't keep up with the chat, just to be honest. So apologize for that. I would like to thank the audience for joining us. We hope you've learned something here today. We hope we're able to get back and answer your questions. We're happy to do it. Thank you so much for joining us. And we hope you join the next seminar in this series, because this is a series of webinars that we host at PNNL. And I think Carly was going to put something in the chat about the next webinar. I think I have the title of it here. The next webinar will be on September 21st at 12 p.m. Pacific. And it's on, the topic is energy storage for grid resilience. And it's going to be moderated by PNNL's Diane Baldwin. So I think there'll be something in the link if it's not already there. I may have already missed it, but thanks again to everyone. If you have questions, please follow up with me. Please follow up with our panelists. And I hope you have a very happy Labor Day weekend. Enjoy your time off, and we'll see you all soon.
Thank you.
Thank you all.
Right.